Now, why do we call this an empty set? It's a simple reasoning. Now, this type of description of sets, like I said, is stated by a rule or set builder. This is a set builder, like I was saying, it can be a formula. So a squared is equal to minus 4. Now you see where a is a real number. Now, a squared equals to minus 4. A cannot be equal to, I'm looking for what a is, because a is an element of capital A. So a squared equals to minus 4, where a is a real number. Now, real numbers can't be negative. So we're looking for members of this set. So this set is a null set, or you can call it a void set, you can call it an empty set. This is the way the question can come in an examination. This is a null set. That is A. It's an empty set. Alright, let's go quickly to properties of the set, and we're done for these lectures. Properties of a set. Properties of a set.
Try.
Now, before we go to the next one, we say properties of a set. So far, I've done define set and identify various types of sets. That's one says describe a set by listing or by rule. Now, we're in the last part of the lesson, which says identify and define various types of set operations. Okay, let's go to the last part of this lesson. Identify and describe various parts of set operations. Let's title it properties of a set. Properties of a set. Now we have equality of set. What does it mean? Say this set is equal to this set. The first one is equality of set. I will get it very closely because it can be quite confusing. Equality of set. Equality of sets. Now, two sets are equal if every element of one is also an element of the other. As easy as that. Two sets are equal if every element of one set is also an element of the other set. If set A and set B have the same element, you say the sets are equal. But there's something else to equality of sets. Let's write this down first. Two sets are equal if every element of one is also an element of the other. Now there are some key notes you have to take. I'll give you two notes concerning equality of sets. Let's write there notes. The first thing you should notice is that, let's give an element of set, two elements of sets. Let's say we have a set containing A, E, I, O, U. And it equals to another element of the set U, O, A, E, I. Now, a set is regarded as being unchanged, even if the order of its elements are changed. Now, if you notice, there's A, there's A here, there's E, there's E here. Now, the elements are the same. The same elements that are here are also the same elements that are here. But the arrangements are changed. So a set is equal even if the elements are changed. Like the arrangement of elements are changed. So let's write it down. A set is regarded as being unchanged. Even if the order as the arrangement, even if the order of its elements are changed. And the first thing we should do, even if the order of the elements are changed, its set is regarded as being unchanged. Even though you arrange the sets, you change the order, putting the first one last or the second one at the middle, the set is regarded as being unchanged. And the second key point to note about equality of sets. The second point to note about equality of sets. Now let's look at something. Another element of sets, let's use the same example for better understanding. A, E, I, O, U. Now equals to A, E, O, U, I. Let's look at these two elements of the set, this and this. Now, the set on either side contain only 5 distinct elements. Now let's count the elements of each set. It contains 5 distinct elements, even though there is a repetition. We have 1, 2, 3, 4, 5 for this side, and this side we have 1, 2, 3, 4, 5. So the set on either side contain only 5 distinct elements. Now, let's do something else to these notes. Repetition of elements play no part in set operation. Repetition of elements plays no part in set operation, and hence elements should never be repeated. Repetition of elements play no part in set operation, and hence elements should never be repeated. Now let's go over to the next property of a set, which is complement of a set. Complement of the set. Let's go to that's what we talk about. Complement of the set. Now, let's take a complement of a set. Complement of a set. That was one. The next one is complement of a set. Complement. Complement of a set. First. Now let's look at complement of the set. That was number 1. Now number 2. Other parts of a set. Complement. Complement of a set. Now what do we mean? Let X be a subset of a universal set U. Let X be a subset. And later I understand what the word subset means. Let X be a subset of a universal set U. The complement complement of x is complement of a set. Let x be a subset of a universal set U. The complement of x is the set of those elements of V that are not in X. Let's take a quick example. For example, if we have a universal set, we have 1, 2, 3, 4, 5, 8, 9, 10. And this is a universal set, our universal set for now. It has elements from 1 to 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's say X. Now X has 1, 2, 4, 6, 8. Now X has the elements 1, 2, 4, 6, 8. As you know, or as I have explained, X is a subset of U, which is a universal set. X is a subset of U. Okay, now let's find the complement of X. Now, complement of X is noted by X is power 1 or X then is power C. X complements. This or this can be this sign here or this sign here can be these two, so that we're looking for the complement of a particular set. Now, like the definition goes, complements of X are members of the universal sets that are not in X. Now let's look at complement of X. Now we have in X, first of all, we have 1, 2, 4, 6, 8. Now, what are the members of this universal set that are not here? That will be equals to, as you know, 3 is not here, but 3 belongs here. 3, 5, 7, 9, 10. This is all about complement of a set. 3, 5, 7, 9, 10. Complement of a set are members of the sets that are not in the other set. Complement of X are members of the universal sets that are not members of X. Let's go straight to equivalent set. At first we treated equality of sets. Let's go straight to equivalent sets. Now, equivalent set. That was 2, this will be 3. Equivalent set. Equivalent set. Now, finite sets which have the same number of elements are safe to be equivalent. And let's take this sharply. Now, finite set is a set that has a limited number of elements. Finite sets which have the same, which have the number of elements. Finite sets which have the same. So let's add the same here. Which have the same number of elements are said to be equivalent sets. Let's take an example just here. We have let X equals to 1, 2, 3. Then Y is equals to A, B, C. Now let's look at the difference. X has how many number of elements? 1, 2, 3. Y has how many number of elements? A, B, C. Now these two sets are said to be equivalent. That is, X is equivalent to Y. As easy as our sets. This should be 4. Let's call it power sets. Now let's say a set A is equal to this element 1, 2, 3, 4, and 5. Now, we are looking for the power set of A. How do we write it? Power set of A is n bracket A. The power set of A. Now, let's count how many elements of A. How many elements do A have? We have 1, 2, 3, 4, 5. So the formula goes power set of A is equal to 2 raised to the power n. 2 raised to the power n, which is equal to n stands for the numbers of elements in the set. We have 5 numbers of elements in the set. That is 2 raised to the power 5, which is equal to 30. Okay,
I did. This is
now the power set is known as power set of A is n bracket A, and the formula is 2 raised to the power n. Now n stands for the number of elements in the set A. We have 1, 2, 3, 4, 5. So to be 2 raised to the power 5. Now 2 raised to the power 5 is what? 32. So the power set of A is 32. As easy as that. Just the number of elements in the set. 2 raised to the power the number of elements in the set. That's how it is being done. And let's go straightly to the last part. Operations between 2 or more sets. Operations now between 2 or more sets, there are some basic operations that happen. Let's go straight to that. We have 3 operations generally that happens between 2 or more sets. Operation between two or more sets. Now, just 3 operations that happen between 2 or more sets, generally everywhere. First one is we have union. We have union. Second one is intersection. The third one is the difference. And let's look at union between 2 or more sets. Let's look at union between two sets. Let's say this is A union B. A union B. This U represents union. A union B. We're looking for the union between A and B, and it's very easy. And let's create the sets A and set B. Then I'll show you how to get the union. Let's see set A. A has its elements small a, B, C. Then set B has its elements B, E, F. Now, the union between A and B is a combination of both the set in A and the set in B. And note, avoid repetition of the union sets. You pick only distinct elements. So A union B are the elements that are A and B. Avoid repetition. So A union B is equal to elements in A and elements in B. We have A, B, C, D, E, F. And this will be all for union between sets. This is very easy. Union between sets. Let's go to the next one. Intersection. Intersection between two sets. Let's say X intersection Y. Now this sign denotes intersection, just like an N. This sign denotes intersection. X intersection Y. Let's take a brief explanation. Now let's say X intersection Y equals to element, that is X will be X element of set A and X element of the set B. Now, this is what it means. X intersection Y is equals to X element of the set A and X element of the set B. That's what our X will be. What this simply means are the common elements of both A and B. Intersection means the common element between A and B. Let's look at the set of X and Y. X is equals to 1, 2, 3, 4, 5. Y equals to 3, 9, 10, 11, 12. Now, intersection means what is the common element between set X element and set Y element. Intersection means what is common. Now we have 1, 2, 3, 4, 5 elements of set X, and we have 3, 9, 10, 11, 12. Now, what is common? I can see basically that 3 and 3 are common. So X intersection Y is equal to 3. As easy as that. And note, for example, if we have two sets, because this can be a question I'm troubling your mind. If we have two sets that has nothing in common, two sets that have nothing in common are called disjoint sets. Disjoint sets. So let's say disjoint sets under intersection. Disjoint sets. A disjoint set is an empty set, null set, or void set. That is X intersection Y equals to, this is P, an empty set, or you write, or just put the bracket and leave it like that. So represent an empty set. Now let's take elements of X and Y, for instance, and what to make them be a disjoint set. You know, when trying to find the intersection, and you get a disjoint set, which is an empty set. Let's say X equals to elements are 2, 4. Y elements are 3, 5. Now we're finding X intersection Y. Now, as I told you before, that intersection means what is common, what is similar. So now let's look at element of X and element of Y. We have 2 and 4 for elements of X, we have 3 and 5 elements of Y. Now, what is common? Notice that there is nothing common. So the intersection between X and Y can be called a disjoint set, which is equal to an empty set or P, as I say we call it earlier. Now let's go straight to the next one. Now let's look at the difference between two sets. We have looked at the union, the intersection, and now let's do the difference between two sets. Difference between two sets. Now you can write the difference between two sets, A and B, like A minus B, or we write A stroke B. Difference between two sets. Now, let's say to find A minus B. To find A minus B, we have a simple law, simple rule. A minus B is equals to A intersection B complement. Find A minus B is equals to A intersection B complement. Now, the difference between two sets, let me explain it, between sets A and B. The difference between two sets belonging to A, difference of two sets belonging to A but not belong to B. Now, the difference of two sets that belongs to A but doesn't belong to B. That was made by A minus B. Now, let's do this fast. Now, let's have our sets. Set A, let's give it an element, let's say 1, 2, 3, 4, 5. Let's give our B is equals to, or B is equals to let's say 1, 3, 5, 9. Let's give our union set. Union set, because we did a union set to find the complement. Union set, let's see, ranging from 1, 2, 3, 8, 9, 10. Let's find, so the formula says A intersection B. So this is A, then intersection B complement. B complement. Let's find B complement because we already have what A is set A, looking for B complement. Now B complement, like I said, are elements of B, or let's look at it this way. This is a universal set, this is B set. So B complements are sets of universal sets that are not a B set. B complements are sets from the elements of the universal sets that are not in the B set elements. Let me go back again. Are elements of the universal sets that are not in the B set elements. So let's look at it. We have 1, 3, 5, 9. 1, 3, 5, 9. So we are looking for B complement. So what is here that is not here? That is B complement. As easy as that. So 1 is here, 2, there's no 2 here, so we have 2. We have 2, 3, there's no 4 here. We have 4, there's 5, there's no 6 here, we have 6. There's no 7 here, we have 7. There's no 8 here, we have 8. There's 9 and there's no 10. So this is B complement. Set B and the universal set. So we have found our B complement. So let's find A minus B. It's equal to A intersection B complement. So let's say A intersection B complement. Now intersection means set. That means elements of sets A and B complements that are similar, that are the same or similar. Let's look at it. We have 2, 4, 6, 7, 8, 10. Then we have 1, 2, 3, 4, 5. So what's our common? We have that 2 is here, 2 is here. We have 2. We have 4 is here, 4 is there. We have 4. Now what is common between the two sets? What again? Okay, we just have 2 elements. 2 and 4. 2 and 4. So as we said, this is equal to this. A minus B is equal to A intersection B complement. So therefore A minus B is equal to this. 2, 4. So A minus B, set A minus set B will give us 2 and 4. That is all for difference between two sets. Now in our next lecture, before we start, we look at what we call Morgan's law. But we won't do that now. Morgan's law. Let me just give you what it states, and for what I've taught, you can just go through it and prove the law. Morgan's law states that brackets A intersection B complement. So the A intersection B complement is equal to A complement union B complement. That was the first Morgan's law states. The second Morgan's law states that bracket A union B all complements is equal to A complement intersection B complement. And so far, this will be all for this lecture. We have discussed a lot. We have defined sets and identified various types of sets. We have described the set by listing or by a rule. We have identified and defined various types of set operations. What is left for us to treat is we will illustrate sets with Venn diagrams. We will illustrate set operation using Venn diagrams, and lastly, we will solve problems on 2 or 3 sets problems using Venn diagrams. See you next time. Alright, thank you very much for watching the educative lecture on sets, part 1. Stay tuned for part 2. We're going to release the part 2 very soon, which is talking about Venn diagrams, like I said in the video. So if you have any question, any contribution, or any other thing, you can just comment below our listing, the video link. Just comment any question you have. Thank you very much.
Yeah, and for those who are interested in engineering drawing, very soon I'll upload our video for engineering drawing. We're going to be starting. We're going to start with a borderline and title block. Those are the most important things in engineering drawing. Okay.
Thank you for watching Protect Prime.
And please, I beg you, subscribe. I beg, we need your subscription.
So subscribe and share the videos to your friends who might be interested.
Sure.
Alright, Protect Prime.